Chapter 5 of The Chemistry of Cookery by W. Mattieu Williams. This LibriVox recording is in the public domain. Recording by Nikki Myers of Gettysburg, Pennsylvania. To learn more about me, visit nikkisessentials.com. Roasting and Grilling. I may now venture to state my own view of a somewhat obscure subject, viz. the difference between the roasting or grilling of meat and the stewing of meat. It appears to me that as regards the nature of the operation it consists simply in the difference between the cooking media, that a grilled steak or chop, or a roasted joint is meat that has been stewed in its own juices instead of stewed in water, that in both cases the changes taking place in the solid parts of the meat are the same kind, provided always that the roasting or grilling is properly performed. The albumen is coagulated in all cases, and the gelatinous and fibrous tissues are softened by being heated in a liquid solvent. I shall presently apply this definition in distinguishing between good and bad cookery. In the roasted or grilled meat the juices are retained in the meat, with the exception of those which escape as gravy on the dish, while in stewing the juices go more or less completely into the water, and the loosening of the fibers and solution of the gelatin and fibrin may be carried further, inasmuch as a larger quantity of solvent is used. Roasting and grilling may be regarded as our national methods of flesh cookery, and stewing in water that of our continental neighbours. The difference between the flavour of English roast beef and French bouillie or Italian manzo is due to the retention or the removal of the saline and highly flavoured soluble materials. Concentrated creatine and creatinine are pungently sapid. The Frenchman takes them out of his bouillie, or boiled meat, and transfers them to his bouillon, or soup, which, with him, is an essential element of a meal. If he ate his meat without soup, he would be like the dogs fed on gelatin by the bone soup commissioners. To the Englishman, with his roast or grilled meat, soup is merely a luxury, not an absolutely necessary element of a complete dietary. What we call boiled meat, as a boiled leg of mutton or round of beef, is an intermediate preparation. The heat is here communicated by water, and the juices partially retained. Not only do we, in roasting and grilling our meat, keep the juices within it, but we concentrate them considerably by evaporating away some of the water by which they are naturally diluted. This is my explanation of the rationale of the chief difference between boiled meat and roasted or grilled meat. A further difference, that due to browning, is discussed in the chapter on frying. Those accustomed to such concentration of flavour regard the milder results of boiling as insipid, for by this process and by stewing, where much water is used, the juices are further diluted instead of being concentrated. It is a fairly debatable question whether the simplicity of taste which finds satisfaction in the milder diet is better and more desirable than the appetite for strong meat. The difference has some analogy to that being the thirst for light wine and that for stiff grog. The application of the principles above expounded to the process of grilling and roasting is simple enough. As the meat is to be stewed in its own juices, it is evident that these juices must be retained as completely as possible, and that, in order to succeed in this, we have to struggle with the evaporating energy of the dry heat, which affects the cookery. It may not only concentrate the juices by driving off some of their solvent water, but may volatilize or decompose the flavouring principles themselves. We must always remember that these organic compounds are very unstable, most of them being decomposed when raised to a temperature above the boiling point of water. The repulsive energy of heat drives apart or dissociates their loosely combined elements, and when thus wholly or partially dissociated, all the characteristic properties of the original compound vanish and others take their place. It should be clearly understood that the so-called dry heat may be communicated by convection or by radiation, or both. When water is the heating medium, there is convection only, i.e. heating by actual contact with the heated body. In roasting and grilling there is also some convection heating due to the hot air which actually touches the meat, but this is a very small element of efficiency, the work being chiefly done, when well done, by the heat which is radiated from the fire directly to the surface of the meat, and which, in the case of roasting in front of a fire, passes through the intervening air with very little effect thereon. I am not perpetrating any far-fetched pedantry in pointing out this difference, as will be understood at once by supposing a beefsteak to be cooked by suspending it in a chamber filled with hot dry air, such as is actively thirsting for the vapour of water, and will take into itself from every humid substance it touches, a quantity proportionate to its temperature. The steak receiving its heat by convection, i.e. the heat conveyed by such hot air and communicated by contact, would be desiccated but not cooked. This distinction is so important that I will illustrate it still further, my chief justification for such instance being that even Rumford himself evidently failed to understand it, and it has been generally misunderstood or neglected. Let us suppose that the hot air used for convection cooking to be at the cooking point, as the hot water in stewing should be. What will follow its application to the meat? Evaporation of the water in the juices, and with that evaporation a lowering of temperature at the surface of the meat, keeping it below the cooking point. If the air be heated above this, the evaporation will go on proportionate rapidly, as nearly 1000 degrees of heat are lost as temperature whenever and wherever evaporation of water occurs. The film of hot, dry air touching the meat is cooled by this evaporation, and sinks immediately to be replaced by a rising film of lighter, hotter, and drier air. This drinks in more vapor, cools, and sinks to give place to another, and so on till the inner juices gradually ooze between the fibers to the porous surface, where they are carried away by the hot, dry air, and a hard, leathery, unmasticatable mass of desiccated gelatin, albumen, fibrin, is produced. Now, let us suppose a similar beefsteak to be cooked by radiant heat, with the least possible cooperation of convection. To effect this, our source of heat must be a good radiator. Glowing solids are better radiators than ordinary flames, therefore coke, or charcoal, or ordinary coal, after its bituminous matter has done its flaming, should be used, and the steak or chop be placed in front or above a surface of such glowing carbon. In ordinary domestic practice it is placed on a gridiron above the coal, and therefore I will consider this case first. The object to be attained is to raise the juices of the meat throughout to about the temperature of 180 degrees Fahrenheit as quickly as possible, in order that the cookery may be completed before the water of these juices shall have had time to evaporate excessively. Therefore the meat should be placed as near to the surface of the glowing carbon as possible. But the practical housewife will say that, if placed within 2 or 3 inches, some of the fat will be melted and burned, and then the steak will be smoked. Now, here we require a little more chemistry. There is smoking and smoking. Smoking that produces a detestable flavor, and smoking that does no mischief at all beyond appearances. The flame of an ordinary coal fire is due to the distillation and combustion of tarry vapors. If such a flame strikes a comparatively cool surface like that of the meat, it will condense and deposit thereon a film of crude coal tar and coal naphtha, most nauseous and rather mischievous. But if the flame be that which is caused by the combustion of its own fat, the deposit on a mutton chop will be a little mutton juice, on a beefsteak a little beef juice, more or less blackened by mutton carbon or beef carbon. But these have no other flavor than that of cooked mutton and cooked beef, therefore they are perfectly innocent in spite of their black, guilty appearances. If any of my readers are skeptical, let them appeal to experiment by putting a mutton chop to the torture, and taking its own confession. To do this, divide the chop into equal halves, then hold 1/2 over a flaming coal, immersing it in the flame, and thus cook it. Now cut a bit of fat off the other, throw this fat on a surface of clear glowing flameless coal or coke, and when a good blaze is thus obtained, immerse the half chop recklessly and unmercifully into this flame. There let it sputter and fizz, let it drop more fat and make more flame, but hold it there, nevertheless, for a few minutes, and then taste the result. In spite of its blackness, it will be, if just warmed through to the above-named cooking temperature, a deliciously cooked, juicy, nutritious, digestible morsel, apparently raw, but actually more completely cooked than if it had been held twice as long, at double the distance, from the surface of the fire. For further instruction, make a third experiment by imitating the cautious, unscientific cook, who, ignorant of the difference between the condensation products of coal and those from beef and mutton fat, carefully raises the gridiron directly the flame from the dropping fat threatens the object of her solicitude. The result will be an ordinary domestic chop or steak. I apply this adjective because in this particular effort of cookery, the grilling of chops and steaks, domestic cookery is commonly at fault. The majority of our city men find that while the joint cooked at home is better than that they usually get at restaurants and hotels, the chops and steaks are inferior. I believe that this inferiority is due, in the first place, to the want of understanding of the difference between coal flame and fat flame, and in the second, to the advantage afforded to the grill room cook by a specially constructed fire, with a large surface of glowing coke surmounted by a sloping grill, whereupon he can expose his chops and steaks to a maximum of radiant heat, with a minimum convection heat, the hot air which passes in a current over the coke surface having such small depth that it barely touches the bars of the grill. This may be seen by watching the course of flame produced by the droppings of the fat. The same obliquity of draught prevents the serious blacking of the meat, which, although harmless, is unsightly and calculated to awaken prejudice. The high temperature rapidly imparted by radiation to the surface of the meat forms a thin superficial crust of hardened and semi-carbonized albumen and fiber that resists the outrush of vapor, and produces within a certain degree of high pressure, which probably acts in loosening the fibers. A well-grilled chop or steak is puffed out, made thicker in the middle. An ill-cooked desiccated specimen is shriveled, collapsed, and thinned by the slow departure or dissociation of its juices. Happy little couples living in little houses with only one little servant, or, happier still, with no servant at all, complain of their little joints of meat, which, when roasted, are so dry, as compared with the big succulent joints of larger households. A little reflection on the principles above applied to the grilling of steaks and the chops will explain the source of this little difficulty, and show how it may be overcome. I will here venture upon a little of the mathematics of cookery as well as its chemistry. While the weight or quantity of material in a joint increases with the cube of its through measured dimensions, its surface only increases with their square, or, otherwise stated, we do not nearly double or treble the surface of a joint of given form when we double or treble its weight, and vice versa. The less the weight, the greater the surface, in proportion to the weight. This is obvious enough when we consider that we cannot cut a single lump of anything into halves without exposing or creating two fresh surfaces where no surfaces were exposed before, as the evaporation of its juices is, under given conditions, proportionate to the surface exposed. It is evident that this process of converting the inside middle into two outside surfaces must increase the amount of evaporation that occurs in roasting. What, then, is the remedy for this? It is twofold. First, to seal up the pores of these additional surfaces as completely as possible, and secondly, to diminish the utmost the time of exposure to the dry air. Logically following up these principles, I arrive at a practical formula, which will probably induce certain orthodox cooks to denounce me as a culinary paradoxer. It is this, that the smaller the joint to be roasted, the higher the temperature to which its surface should be exposed. The roasting of a small joint should, in fact, be conducted in nearly the same manner as the grilling of a chop or steak, described in my last. The surface should be crusted or browned, burned, if you please, as speedily as possible, in such wise that the juices within shall be held there, under high pressure, and only allowed to escape by burst and splutters, rather than by steady evaporation. The best way of doing this is a problem to be solved by the practical cook. I only expound the principles and timidly suggest the mode of applying them. In a metallurgical laboratory, where I am most at home, I could roast a small joint beautifully by suspending it inside a large red-hot steel smelter's crucible, or, better still, in an apparatus called a muffle, which is a fire-clay tunnel, open in front, and so arranged in a suitable furnace as to be easily made red-hot all around. A small joint placed on a dripping pan and run into this would be equally heated by all-around converging radiation, and exquisitely roasted in the course of 10 to 30 minutes, according to its size. Some such apparatus has yet to be invented in order that we may learn the flavor and tenderness of a perfectly roasted small joint of beef or mutton. For roasting large masses of meat a different proceeding is necessary. Here we have to contend not with excessive surface in proportion to bulk, as in the grilling of chops and steaks, and the roasting of small joints, but with the contrary, viz. Excessive bulk in proportion to surface. If a baron of beef were to be treated according to my prescription for a steak, or a single small wing rib, or other joint of 3 to 5 pounds weight, it would be charred on its surface long before the heat could reach its center. A considerable time is here inevitably demanded. Of course, the higher the initial outside temperature, the more rapidly the heat will penetrate. But we cannot apply this law to a lump of meat as we may to a mass of iron. We may go on heating the outside of the iron to redness, but not so the meat. So long as the surface of the meat remains moist, we cannot raise it to a higher temperature than the boiling point of the liquid that moistens it. Above this, charring commences. A little of such charring, such as occurs to the steak or small joint during the short period of its exposure to the great heat, does no harm. It simply browns the surface. But if this were continued during the roasting of a large joint, a crust of positively black charcoal would be formed, with ruinous waste and general detriment. As Rumford proved long ago, liquids are very bad conductors, and when their circulation is prevented by confinement between fibers, as in the meat, the rate at which heat will travel through the humid mass is very slow indeed. As few of my readers are likely to fully estimate the magnitude of this difficulty, I will state a fact that came under my own observation, and at the time surprised me. About 25 years ago, I was visiting a friend at Warwick during the Mop, or Statute Fair, the annual slave market of the county. In accordance with the old custom, an ox was roasted whole in the open marketplace. The spitting of the carcass and starting the cookery was a disgusting sight. We are accustomed to see the neatly cut joints ordinarily brought to the kitchen, but the handling and impaling of the whole body of a huge beast by half a dozen rough men, while its stiffened limbs were stretching out from its trunk, presented the carnivorous character of our ordinary feeding very grossly indeed. Nevertheless, I watched the process, partook of some of its result, and found it good. The fire was lighted before midnight. The rotation of the beast on the horizontal spit began shortly after, and continued until the following midday, all this time being necessary for the raising of the inner parts of the flesh to the cooking temperature of about 100 degrees Fahrenheit. Compare this with the grilling of a steak, which, when well done, is done in a few minutes, or the roasting of a small joint as above within 30 minutes, and you will see that I am justified in dwelling on the great differences of the two processes, and the necessity of a varied proceeding to meet these different conditions. The difference of time is so great that the smaller relative surface is insufficient to compensate for the evaporation that must occur if the grilling principle, or pure and simple action of radiant heat, were only made available, as in the above ideal roasting of the small joint. What, then, is added to this? How is the desiccating difficulty overcome in the large-scale roasting? Simply by basting. All night long, and all the next morning, men were continuously at work pouring melted fat over the surface of the slowly rotating carcass of the Warwick ox, skilfully directing a ladleful to any part that indicated undue dryness. By this device the meat is more or less completely enveloped in a varnish of hot melted fat which assists in the communication of heat, while it checks the evaporation of the juices. In such roasting the heat is partially communicated by convection through the medium of a fat bath, as in stewing it is all supplied by a water bath. I have made some experiments wherein this principle is fully carried out. In a suitably sized saucepan I melted a sufficient quantity of mutton dripping to form a bath, wherein a small joint of mutton could be completely immersed. The fat was then raised to a temperature of 350 degrees, as shown by Davis' triometer, presently to be described. Then I immersed the joint in this, keeping up the high temperature for a few minutes. Afterwards I allowed it to fall below 200 degrees, and thus cooked the joint. It was good and juicy. Though a little of the gravy had escaped and was found in the fat after cooling, the experiment was repeated with variations of temperature, the best result obtained when it was about 400 degrees at the beginning, and kept up to above 200 degrees afterwards. I used loins and half legs of mutton, exposing considerable surface. I find that Sir Henry Thompson, in a lecture delivered at the Fisheries Exhibition, and now reprinted, has invaded my subject, and has done this so well that I shall retaliate by annexing his suggestion, which is that fish should be roasted. He says that this mode of cooking fish should be general, since it is applicable to all varieties. I fully agree with him, but go a little further in the same direction by including not only roasting in a Dutch or American oven before the fire, but also in the side ovens of kitcheners and in gas ovens, which, when used as I have explained, are roasters, i.e., they cook by radiation without any of the drying anticipated by Sir Henry. The practical housewife will probably say this is not new, seeing that people who know what is good have long been in the habit of enjoying mackerel and haddocks, especially Dublin Bay haddocks, stuffed and baked, and cod's heads similarly treated. The Jews do something of the kind with halibut's head, which they prize as the greatest of all piscine delicacies. The John Dory is commonly stuffed and cooked in an oven by those who understand his merits. The excellence of Sir Henry Thompson's idea consists in its breadth as applicable to all fish, on the basis of the fundamental principle of scientific cookery, on which I have so continually and variously insisted, viz., the retention and concentration of the natural juices of the viands. He recommends the placing of the fish entire, if of moderate size, in a tin or plated copper dish, adapted to the form and size of the fish, but a little deeper than its thickness, so as to retain all the juices, which on exposure to the heat will flow out. The surface to be lightly spread with butter, with a morsel or two added, and the dish placed before the fire in a Dutch or American oven, or the special apparatus made by Burton of Oxford Street, which was exhibited at the lecture. To this I may add, that if a closed oven be used, Rumford's device of a false bottom, shown in Fig. 3, page 72, see next chapter, should be adopted, which may be easily done by simply standing the above described fish dish on any kind of support to raise a little, in a larger tin tray or baking dish containing some water. The evaporation of the water will prevent the drying up of the fish, or of its natural gravy, and if the oven ventilation is treated with the contempt I shall presently recommend, the fish, if thick, will be better cooked and more juicy than in an open-faced oven in front of the fire. This reminds me of a method of cooking fish which in the course of my pedestrian travels in Italy I have seen practised in the rudest of osterias, where my fellow guests and carbonari, charcoal burners, waggoners, road-making navvies, their staple magro, or fast-day material, is split and dried codfish, imported from Norway, which in appearance resembles the hides that are imported to the Bermondsey tanneries. A piece is hacked out from one of these, soaked for a while in water, and carefully rolled in a piece of paper saturated with olive oil. A hole is then made in the white embers of the charcoal fire, the paper parcel of fish inserted and carefully buried in ashes of selected temperature. It comes out wonderfully well cooked, considering the nature of the raw material. Luxurious cookery en papillote is conducted on the same principle, and especially applied to red mullets, the paper being buttered and the sauce enveloped with the fish. In all these cases the retention of the natural juices is the primary object. I should add that Sir Henry Thompson directs as a matter of course that the roasted fish should be served in the dish wherein it was cooked. He suggests that portions of fish, such as fillets, may be treated as well as the entire fish. Garnishes of all kinds, as shellfish, may be added, flavoring also with fine herbs and condiments according to taste. Fillets of plaice or skate, with a slice or two of bacon, the dish to be filled or garnished with some previously boiled haricot, is widely recommended as a savoury meal for a poor man, and one that is highly nutritious. A chemical analysis of 6 pennyworth of such a combination would prove its nutritive value to be equal to fully 18 pennyworth of beefsteak. Some people may be inclined to smile at what I am about to say, viz., that such savoury dishes, serving to vary the monotony of the poor hard-working man's ordinary fare, afford considerable moral, as well as physical, advantage. An instructive experience of my own will illustrate this. When wandering alone through Norway in 1856, I lost the track in crossing of the Kjollen Field, struggled on for 23 hours without food or rest, and arrived in a sorry plight at Lom, a very wild region. After a few hours' rest, I pushed on to a still wilder region and still rougher quarters, and continued thus to the great Jostedal tableland, an unbroken glacier of 500 square miles, then descended to the Jostedal itself, to its opening, Sognefjord. 5 days of extreme hardship, with no other food than flat brod, very coarse oatcake, and bilberries, gathered on the way, varied on one occasion with the luxury of 2 raw turnips. Then I reached a comparatively luxurious station, Ronay, where ham and eggs and claret were obtainable. The first glass of claret produced an effect that alarmed me, a craving for more and stronger drink that was almost irresistible. I finished a bottle of St. Julian, and nothing but a violent effort of will prevented me from then ordering brandy. I attribute this to the exhaustion consequent upon the excessive work and insufficient unsavory food of the previous 5 days. Have made many subsequent observations on the victims of alcohol, and have no doubt that overwork and scanty, tasteless food is the primary source of the craving for strong drink that so largely prevails, with such deplorable results, among the class that is the most exposed to such privation. I do not say that this is the only source of such depraved appetite. It may also be engendered by the opposite extreme of excessive luxurious pandering to general sensuality. The practical inference suggested by this experience and these observations is that speech-making, pledge-signing, and blue-ribbon missions can only effect temporary results until supplemented by satisfying the natural appetite of hungry people by supplies of food that are not only nutritious, but savory and varied. Such food need be no more expensive than that which is commonly eaten by the poorest of Englishmen, but it must be far better cooked. Comparing the domestic economy of the poorer classes of our countrymen with that of the corresponding classes in France and Italy, with both of which I am well acquainted, I find that the raw material of the dietary of the French and the Italians is inferior to that of the English, but a far better result is obtained by better cookery. The Italian peasantry are better fed than the French. In the poor osterias above referred to, not only the Friday salt fish, but all the other viands, were incomparably better cooked than that in corresponding places in England, and the variety was greater than is common in many middle-class houses. The ordinary supper of the roughs above named was of 3 courses. First, a minestra, a soup of some kind, continually varied, or a savoury dish of macaroni, then a ragout, or savoury stew of vegetables and meat, followed by an excellent salad, the beverage a flask of thin but genuine wine. When I come to the subject of cheese, I will describe their mode of cooking and using it. My first walk through Italy extended from the Alps to Naples, and from Messina to Syracuse. I thus spent nearly a year in Italy during a season of great abundance, and never saw a drunken Italian. A few years after this, I walked through a part of Lombardy, and found the little osterias as bad as English beer shops and low public houses. It was a period of scarcity and trouble. The 3 plagues, as they called them, the potato disease, the silkworm fungus, and the grape disease, had brought about general privation. There was no wine at all. Potato spirit and coarse beer had taken its place. Monotonous polenta, a sort of paste or porridge made from Italian cornmeal, to which they give the contemptuous name of miserabile, was then the general food, and much drunkenness was the natural consequence. End of Chapter 5. Recording by Nikki Myers of Gettysburg, Pennsylvania. To learn more about me, visit nickysessentials.com.